You know that feeling, right? You're using your favorite AI app, you're in the zone, and then poof, it just breaks. Why does that happen so often? Well, in this explainer, we're going to pull back the curtain and look at how engineers make AI not just smart, but strong. We're talking about making it truly reliable. Let's dive in.
Oh yeah, it's that classic sinking feeling. You're trying to get something done, you ask the AI for help, and you get the spinning wheel of death. Or maybe a super unhelpful error message. It's more than just annoying, you know? It kind of breaks your trust in the tool. So what is actually happening behind the scenes?
And here they are, the usual suspects. You've got the loading icon that just spins forever, the classic vague, something went wrong message, and my personal favorite, when the AI just stops talking, mid-sentence. These aren't just random glitches, they're symptoms of a bigger problem. They're signs that the AI system just isn't built for the chaos of the real world.
So what is the real story here? Well, it's not just one single thing. You got to think of it like a giant, complicated game of telephone. Your request has to travel from your phone or computer all the way across the internet to some massive AI server, and then all the way back. And at any point in that journey, something can go sideways. Let's break down exactly where things tend to fail.
Okay, to fix the problem, you first have to figure out where it's coming from. We can pretty much narrow down these digital hiccups to three main areas. First up,
So first, you've got client-side errors. This is basically a problem with the message you sent. Think of it like you sent a letter with the wrong address or a typo in the name. Maybe the API key, the password, was wrong, or your question was just way too long for the system to handle. Then you have provider-side errors. This is when the AI's home base is having a bad day. Their servers might be overloaded, or you might have hit a rate limit, which is like asking too many questions too fast. And finally, you have the weirdest one of all, application-level errors. This is when the AI actually answers, but the answer is just broken. It's gibberish, or it's formatted incorrectly. It's like it tried to talk, but just stumbled over its own words.
Okay, so something breaks. What's the very first decision an engineer has to make? It's a really simple question, but it has a huge impact. Do we just try again? The answer to that question is really the foundation of building a robust AI system.
And this is where you have to split the world of errors in two. On one side, you have temporary errors. These are things that might just fix themselves. You know, a quick network blip, a server that's busy for just a second. For these, yeah, retrying is a good idea. But then you have permanent errors. These are the dead ends, the brick walls. If you have the wrong password, trying it 1,000 more times isn't going to magically make it the right one.
And here's the best way to think about it. It's such a simple analogy. A temporary error is like getting a busy signal on the phone. What do? You hang up and call back in a minute. But a permanent error? That's like dialing a completely wrong number. You can call that number all day long and you're never going to reach the person you're looking for. The absolute key is to only retry when it actually has a chance of working.
So knowing when to retry, that's step one. But how you retry, that's where you separate the amateurs from the pros. So let's pull back the curtain and look at the actual playbook the pros use to build these super resilient AI apps. The first pro move has a fancy name, exponential backoff. But the idea is super simple. Instead of just hammering the server again and again with retries, you give it a little room to breathe. You try, you fail, and then you wait just a little bit before you try again. It's polite, and it's way more effective.
And here's exactly how it works. The first time you fail, you wait 1 second. The second time, you wait 2 seconds. The third, you wait 4 seconds. You see the pattern, right? You double the wait time with each failure. This clever escalating delay gives a stressed-out server a chance to catch its breath, which makes it way more likely that your next attempt will actually succeed.
Okay, but what if even your smartest retries don't work? You've backed off, you've waited, and you're still getting nothing. Now what? You can't just leave your user staring at a blank screen. This is where the truly great apps show their quality, because they always have a plan B.
This is what's called the art of the graceful fallback. The system basically says, okay, plan A isn't working, let's switch to plan B immediately. Maybe that means it tries a totally different backup AI model, or maybe it shows you a saved answer from a similar question that worked before, or at the very least, it gives you some helpful info instead of just an error. The goal is to never, ever leave the user at a dead end.
Now this next trick, this one feels like actual magic. It's called self-repair. So imagine the AI is supposed to give you data in a really specific, clean format, but it messes up one little detail. Instead of just throwing that response away, a really smart system will actually go back to the AI and say, hey, you almost got it right, but you messed up the formatting right here. Can you please fix it for me? It is literally using the AI to fix the AI's own mistakes. How cool is that? All right, we have covered a ton of ground here. We've talked about diagnosing problems, retrying smartly, and having graceful fallbacks. Now it's time to put all those pieces together into the ultimate blueprint for a truly bulletproof AI.
And here it is. This is the entire journey of a single super robust request. First, you check the input right at the front door. Make sure it's safe and not too big. Then, you call the AI armed with that smart retry strategy. If you hit a wall, you make an intelligent choice. Retry or switch to plan B. When you finally get an answer, you check it to make sure it's not broken. If it is, you try that self-repair trick. And all the while, you're logging everything so you can learn from what went wrong. It all ends with a clean, useful response for the user. This is how you build an AI that doesn't just work sometimes, it works all the time.
So let's just boil this all down into a super handy cheat sheet. This is basically the pro playbook in a nutshell. Are you getting network errors? Use exponential backoff. Is the AI giving you weird, malformed output? Validate it, and then try self-repair. Is the whole AI provider down? No problem. You've got a fallback to another model ready to go. This isn't just a list of tactics. It's a complete mindset. It's about expecting failure and having a smart solution ready for every single scenario.
So why go through all this trouble? What's the point? It's all in the pursuit of one magic number, 99.9%. In the industry, they call this 3 nines of reliability. It means that for every 1,000 times you use the app, it might fail once. That's the goal. It's about taking this wild, unpredictable AI technology and taming it with really smart engineering so that for you, the user, it just feels like it always works.
And that really brings us to the biggest takeaway of all. In the world of AI, things will go wrong. It's not an if, it's a when. A great AI app isn't one that never encounters an error. It's one that fully expects errors to happen and has a brilliant plan for what to do when they do. The real failure isn't the error itself. The real failure is being surprised by it. So the next time your favorite AI tool works perfectly, just take a second to appreciate all the invisible engineering, all that planning for failure that makes it feel so effortless. It's not magic, it's just really, really good design.